Uh, in the world of this blockchain and blockchain development, there are so many tools that we can use to develop the smart contract. So here is a IDE called Remix, which is online IDE, and another one is Truffle. And then of course there are some other like Hardhat. And in this video, we are gonna compare the Remix and Truffle, and eventually we are gonna use the TypeScript on Truffle, because Truffle has the built-in JavaScript test function. But as you might know, the JavaScript is not a uh, typing language, so it's not error-free. We often use much time on debugging the JavaScript code. It's especially on the blockchain. Uh, it is very difficult to know where it goes wrong inside the blockchain integration. So if we use the JavaScript, it gets more difficult to find out the bug. So in this case, we are trying to integrate the truffle with the TypeScript at the end of this video. Okay, so what we are going to do is now first we are gonna make a smart contract, a very simple smart contract, which is a staking, which is a one ERC token, which is as you can see here, the color token, and another one is a stake contract, which has the built-in proof token, as you can see here. This is called PCTK, is proof color token. And how it works is that firstly, user will stake their CTK token to get into the staking contract, and then the staking contract will mint the proof CTK token to the user to prove that this user has the proof token. Once they want to withdraw it, and then they will be able to do that. And then this is the second case. If user want to unstake their staked CTK, they will need to call the function unstake function, and then unstake function will get back the proof token, CTK token, and then return the CTK token back to the user. And because it is a staking platform, the most important thing is that we need to give user reward as the incentive to let user to stake in our platform, right? So we need to implement the reward factor, and there are two methods to do so. And then the first one is that we can use the current timestamp and the gap between the current timestamp and the user's dead time point, and then times one way. And then it means that each interval of time will increment one way, no matter what interval, how long the interval is. For example, if we set it as like 1 hour, the user will get 1 way, or 1 second. Both are okay. But in this case, we will need to remember every single user stake time point. This is kind of not only hassle, but also consuming the gas of the user, because this is blockchain. The more thing you want to store in the blockchain, the more cost you need to pay. So this is not a good idea. So we are going for the next better approach. This is it's kind of mathematic thing. So when user stake, they will get back the CTK amount that they input divided by the current timestamp minus deployed time. So, and then when on stake, they will get back the CTK of that inputted PCTK times the timestamp of now minus deployed time. So that's all. That is the formula. And this is not the important thing. The most important thing is that we get our reward working well, and then we will need to go into our main point, which is using Remix or Truffle, and then we will compare both of it, and then we will eventually use the TypeScript. We will integrate TypeScript into the Truffle framework. Okay, without further ado, we are going to get into the coding section. So we will use the firstly Remix. Like this, we just Google Remix, and then we will see the first one is the Remix IDE. Okay, and you can see the interface of the Remix, and now the main point is that we can create a new workspace, and we can select the template, and it's very considerate that it's already have the OpenZip ERC20 for us. We just select this one, and then we use default one, so we don't need to click anything. We will do it by ourselves. So okay, and then that you can see now we have the contract which contains the my token. I think this one is the one we need, the ERC, very plain ERC20 token. And then you might, so this ERC is imported from the OpenZeppelin. And then very good thing is that the remix help us to import the importing status, import the library from our importing status. So for example, so as you can see now, the OpenZeppelin now they have already remix already helps us to like doing such thing, and then you can see the ERC20 here. Okay, so for example, if I want to import another contract from OpenZeppelin call well, I remember it will be access, and this one is access control. Don't forget the semicolon, and you can see now the access control contract call also be automatically imported. Okay, so now we're gonna make use of the our token. So we just firstly change the name. We are gonna call it probably color token, right? And the contract is this one should be name, right? The color token, and maybe we just let the deployer to input the name of the token and name and symbol of the token by themselves. So we are not gonna do this. We are gonna put it as an argument, like string memory token name and string memory token symbol. And we also need to have the total supply, right? uint. Why it doesn't highlight it? uint. Okay, and here we are gonna use the token name, which is provided by the deployer, and the total and the token symbol. And I think we can we just go back to ERC20 to see the constructor, and it has name and symbol, and we should be able to set the total supply. Okay, this one, total supply. So what we need to do, and no, we can just mint it. Okay, that's it. So this one is the total supply that we need to mint. Okay, and we need to mint to, we will firstly mint to the sender of the deployer and the total supply. Okay, and that's it, I believe. Give me a highlight. Okay, here is a unneeded column. Okay, and the next one is that we will need to, because as you can see, we bust of the contract. Oh, sorry, we need to get to the second page, which is the detail of the contract. So we will have two contracts. One is the CDK, and then another is the proof CDK, which is the staking contract plus the PCDK contract, which is also a ERC20 token contract, but with staking feature. Okay, so what we need to have is this: when user stake, for example, 10 CDK, and then the CDK will burn, CDK ERC20 contract will burn CDK 10, and then the PCDK token will mint 10 to the staker. And then when it goes to unstake, for example, if the user stake 10, unstake 10 PCDK, and then CDK will, this one shouldn't be like this, plus reward. So the CDK will mint 10 plus reward, and then send back to mint 10 plus reward to the user. And pctk will be burned. Okay, so this one is this as well. This one needs to be changed to reward. Okay, so that's two contracts that we need to create. Okay, so as just mentioned that we need to create the mint function and address 2, and we will also need to let user to input the amount, and this should be the external. And we will also need to have another function which is burn, and also need to have the address from who and then amount, and then this is also external. So this is all function that we need, and then we need to have another contract as we just mentioned before, but before creating that we just changed the name of our contract because it is not my token. This should be CDK, right? Okay, and we just copy, because as you might remember, the staking platform, the staking token is also a ERC20 token, so it is the ERC20 token with staking function. So we are going to change the name to pCTK because it is the ERC20 token of pCTK, proof CTK. Okay, and this is just an example. We can just delete it, and okay, we don't need, because this token has the initial amount of 0, so we don't need the total supply, and we do need the token name and token symbol is the same, and then we don't need to mint, right, because the initial amount is 0. Okay, that's it. Okay, and remember that we also need to have some because this is the there is the important thing that this staking token need to distribute reward, and then to do so we will need to have a timestamp of the deployed time stamp, and then we will need to set it as the deployed time, okay, will equal to the time when the deployer deploys the deploys the contract. This is should be timestamp. Okay, and we are going to change this to proof CDK. Okay, and I think we are pretty much done with this. Okay, and then another important thing is that we need to let the staking contract, let's go back to our graph, we need to let this staking contract to have the control of the CDK, so that this staking contract is able to ask CDK to mint and burn. Okay, so we will need to have the MTK. We will need to have the need to import ctk.sol, and I always forget the semicolon, and we will be C color token, and we call it CDK. Good, and the CDK will be, we need to import the CDK as well. Color token equal to color token. Okay, so I think that's it, and we actually don't need this too, because we are not gonna let anybody to mint and burn, but instead it will have the stake function, and then we will need to input the amount, how much the user want to stake, and what happens. Identifier not found. CTK, let me see. Wow, I think we make a mistake, but it's fine. I just mistaken to modify the file of the CTK instead of pCTK. So we change the name. Rename and this one should be pcdk, and this one should be ctk. Okay, so in the pcdk we can import the ctk. It's correct now. And what's happening here is that did you intend to add the public? All right, so user need to, we might use the public. Okay, that's good. And we are gonna have another function is onStake, right? onStake, and we also need to have the amount, and then it's a public function. And now I think that's pretty much we need. And then so the next we need to fill in the function, the logic of the function. So what should we do? We go for the ctk first. Okay, so in the mint we will need to have, firstly we will need to make sure that oh, and one thing we need to do is that we remember this graph, the CTK staking platform, the contract will ask CTK to burn or mint. It means that CTK will be controlled by the proof CTK, which is the staking token. So very importantly, when you want to use the one contract to control another contract function, we need to have the access to this another contract, and then it's kind of fairly simple. We can use the access control. That is the reason that I import the access control here. So we are going to use the I think is access control. Okay, and we will need to make a rule that when somebody or some smart contract has this rule, and it will be able to mint or burn. So if they have the minter rule, it means they will be able to mint. So it will be minter rule. Okay, good. And another one is burner rule, right? It is in the 32-byte format rule. Okay, now we have the rule, and now we need to set the initial rule. Set the initial rule to the default default admin to the deployer. That way, the deployer is able to grant the rule, for example, minter rule or burner rule, to the staking contract. Okay, and in the mint and burn, that's important. We need to, let's go to see what's happened in the access control and then what we can do. And as you can see in the access control, we will have the only rule, right? So only rule means that if somebody or some that want to control the contract has the role of something, in our case it's minter or burner, and then it is able to access or the mint or burned it. Okay, let's go back to here. So it's very simply we just say only rule of should be minter rule. Pretty cool. And then the logic will be mint to amount. Pretty straightforward. And this will be we need to set the access controls with only rule of burner rule. Remix is honestly kind of good for the autocomplete, so I don't need to type so many things. Burn from amount. That's great, and I think that's all we need to do for the CDK contract. But it is yawning. What is this? Oh, I forgot. I think I forgot the semicolon or not. No, it's not but good constructor. Okay, so I forgot the semicolon here. Okay, that's good. And then the next one is our pCDK. Let's go for the stake part first. Now we need to, this part is kind of difficult, but this is we just get through it very quick. P CTK equal to amount block timestamp develop timestamp 1 times 60 times 60. It means this is the unit time interval of 60 minutes. Okay, pretty cool. And then next is the int. We might say it out, and then this is the CTK out, because this is the CTK that user will get when they do the unstake, and then this will be amount times it's gonna be the same as this one. Okay, pretty cool. And this is the what we just mentioned on the graph here. And the next one is the we need to burn and mint, right? So firstly we need to mint to sender the p ntk CTK out, and then we need to burn the CTK as we just mentioned, burn and the sender and amount. Okay, pretty cool. That's it. So what's happening? I forget this again. Okay, and the same thing, we need to burn the amount of pCTK, and we need to mint the amount of the CTK out, which is calculated here, Okay, and semicolon, don't forget again. I remember that's all. I think this is pretty much CTK. What's happening? pCTK out. Oh, here it's CTK, not NTK. It's a CTK. I don't know why I typo so much. Okay, that's it. And then one extra function is a helper function, because we don't want user to be able to transfer the pCTK token when they try to stake. So we just try to make a constraint to not let user to transfer. So we are going to make use of the before token transfer, which is the default is a built-in function for the ERC20. So we just override it, and this will be the internal function. And we just set it well. Let's go to the ERC20 to see what is the argument before token transfer here. So it's address from to amount. We copy it and put it into our contract here, and we just format it a little bit, and that's it. And then we are going to make a constraint require, because we still need to let user to mint or to burn. Mint means that user the contract will mint the token to certain user from the address of 0, and burn means that the contract will burn the token from the user by the token by the address of 0. So this is simple. We need to make sure that from is not address of 0, or the to is not address of 0, otherwise the pCTK will be yelling not allowed to transfer proof token, and we are gonna call the super before transfer function, and that's it. So that's the contract, the two contracts that we need to make, and then we can try to compile it and see how will it be working. Okay, it's just a warning. We don't, yeah, that's fine. And we just try to deploy it. Now firstly we deploy the CTK, and first one is token name is the color token and symbol is CDK, and total supply we make it 100,000 and confirm. Okay, it's done, and then you will see the contract is here, deployed contract here, and then next we will deploy the PCTK, which is the staking contract. So the token name is P proof CDK, and it's P CDK, and the color token is the address of this one. So we copy this and then pass it here, transit. Okay, then it's done as well. Okay, and the next one is that we need to grant the role, burner role and minter role of the color token to the proved CDK, which is the staking contract. Okay, let's go to the proof token. No, let's go to the color token, and you see there is a grant role, and we need to grant the role to this proof CDK. So we copy this and then put it inside the account argument of the grant role. And what is the role? We need to know the minter role. What is the minter role and burner role? So we scroll down, we will be able to see there's a burn role here, and then you click, you see there is the burn role here, and then we copy this and then put it here. Make sure everything is right, and then transact, and then it's good. And then we will find another role, which is the minter role here, and click it, and you will be able to see the 22 bytes format of the minter role. And then we again change this, and copy and paste, and transact, and it's okay. And we can now try to stake to see if it is working. Okay, let's try to stake, because I'm using remember that we mint all the total supply of the CDK to the deployer, so we will be able to see I should have the 10,000 100,000 of the CDK, and then the total supply will be 100,000 is correct, and we can see the balance of myself, or what is myself, this one, copy it, and we see balance of myself should be 100,000 is cool. And we go to the another contract, which is a staking contract here, proof token, and then we stake. I have 100,000, and then I just put 1,000 to see if I can stake. Cool, and it's done. And then I will go back to see if I correctly stake it, and then I will see to see here now the balance. Before the balance was 100,000, and then I check it again, it's 99,000, and it means I just did the stake 10,000, and then it will burn, right? It burned, right? So remember that, and it turns to 99,000. So it's pretty good. We did everything done in by the remix, but remix is not really good experience on the developing the smart contract, because when you go to the test or scripting, it's gonna be kind of hassle. So we are going to make use of truffle. Okay, now we have done making the contract by remix, but that is not our goal. Our goal is making the contract by the truffle DX, and then try to make a test of the contract. Okay, so firstly, we just go to the our terminal, and we try to make sure that you have already installed the truffle globally, and if you do not, you just use the truffle -g npm install -g truffle, and that's it. I've already installed it, so I don't need to do that. If you do not, you just install it, and we can make a project for directory called I don't know, ts staking. Okay, we just make it more general name, truffle ts boilderplate. It should be good. Okay, and then let's get into it. Copy it. Okay, and we now in the project folder, and then firstly we just make the CS code of this. Okay, now the folder is empty. Now we just try to init truffle init. and you will be able to see the boilerplate of the truffle, and then you will be able to see everything is in JavaScript, and then truffle doesn't supply any TypeScript template for us, so this is definitely not what we want, so I just remove it. Okay, now so what should we do? There is luckily a tool called typechain. We can just go to the Google and search typechain GitHub, and this is the provided project, blockchain project with the type. And let's go to the README, and then you will be able to see the detail of it. And go down to here, and then you will be able to see there is the truffle v5 type chain, and then truffle version 5 support it, and it says that we static type, and then ID supported, TypeScript is perfect. Oh, this is what we need, and then we just see the example. No, we probably just clone it all. We simply clone the project, copy, and go here, and we git clone. And after cloning this, you will be able to see all the type chain instant inside. I think we can check the example here, and here is what we want, truffle v5, and this is only thing we need. So what we can do is move, copy the file to the root folder of the project, here to here. Pretty cool. And we can remove this one. Okay, now we have the only truffle v5. I think that's pretty cool. And as you can see now, everything is in TypeScript. It's cool, migrate, also TypeScript. Okay, and we don't want all these files inside the truffle v5 folder. We just move it, move everything in the truffle v5 to here. Oops. Well, that's pretty weird. We probably do it directly from the GUI move. Okay, and then we can delete this because empty folder of truffle-v5. Okay, that's it. And let's go through all this. The contract is the contract we need, and the migration is exactly the same as the truffle in this version, but with type, which is cool. And type, it has the template for us. This is the example, but as you can see here, it doesn't have type support. This is the only point that the type chain doesn't do good, but we are gonna change it to type supported. Okay, and here is a package JSON, and then all the dependency that we need, and then it has those things, and that's pretty good. And then it has the migration config, migration specific TS config, and general TS config. So it means that if we do the yarn or npm migrate, it will compile TS TypeScript, compile everything inside here and output to the migration folder, and then use the truffle migrate. Okay, and this is the project config file, which is this one, and this one says this is extended from the TS config, the general level, and then includes means that only compile this all the TS file inside the TS migration TS folder and then types folders. Okay, so that's it. And then firstly, we can try if it is working fine or not. And I believe, let's go back to the package.json, and we can try yarn generate types. Oops. Oh, we need to install first. Yarn install. Oops. What's happening? Doesn't have yarn. Okay. and then it says like what type chain we want to use. We just use the newest one, and then this is the type chain, a version of type chain. We also use the newest one, and I think that's all. And then it would take a little bit time to install all the dependency, and after that we are gonna run this generate types and it will generate some types for us. It will have a new type it here, as you can see. We probably just use this type check, okay, and it will compile our code, contract code in contracts folder, and then it will call the generate type. This one should not be PNPN because we are using yarn, okay, and then it will call this one, and then this one is the one to generate the types folder, and then it will call the TSC. I believe we don't need this. So we probably just leave it here. Okay, let's try yarn type check, and you will see here the compiled, right? And then next one you generate a type, and you can see here types comes out, and next is TS no emit, so it doesn't make any effects for now, but it's fine. And then next one we will be able to test, so we can just use the truffle test. Oops, truffle test. It's gonna be not be working because we don't have the chain yet, right? So we are gonna use the truffle ganache CLI to create the local blockchain. Oops. Create a local blockchain. Oops. Just set up my NPM environment. Oops. Well, okay, now we have our local blockchain up and running, and we can run test again. Okay, has not been deployed. Okay, we haven't migrated. Okay, because we don't have the migration JS for now, so that means it will be not able to see, the truffle will not be able to see the migration, so if the test will not be able to migrate things. So we forgot this one. We need to try to compile the thing, every TypeScript file, and then create a migration folder, and then we probably don't need to run this one. Okay, let's do this. Give it a try. Yarn migrate, and then you will be able to see it helps us to generate the migration. That's great. And now we try to use the truffle test again, and cool, it's done. And you might think, wow, cool, the test, if the test has been gone through, so the test also support TypeScript. As you might have already known, most of you develop the smart contract milestone already known that it's the most difficult part to develop the smart contracts debug and then try to make the test for the smart contract, because it's no type. It's very difficult to debug, and then when you try to use for example Web3, and then if it is JavaScript, you don't have this type, you don't know what is inside the if, so it's difficult, and then you need to guess all the time. But when you have the TypeScript supported, it's much easier, so you make your life much easier. But let's try one thing. If we want to create a constant a, and then it is a string, and then we say it's probably the test. Okay, that's it. And then we try to run the test again. It shouldn't affect anything, and it shouldn't affect the result, but you will see the error right away here, because it doesn't say a. It says that a, this one missing the initializer of the constant, means that it still uses the JavaScript to because it is still a truffle framework. It still uses the JavaScript to even though to run the script, even though it is in the TS format, but you know that it doesn't work. So now we are gonna make a little bit change of the TypeScript config as well as the package config. So firstly, okay, firstly, we don't need this one, right? What is the target truffle v5? We don't need this. And then this one, we change to the name of our project. This one should be cool. Okay. And true, everything is good. And TypeScript, generate type is pretty cool. And we need the type check. This is the important part, so we don't let it this now part, we make a second part. And is the truffle compile correct? We probably need to reset it every time because our computer is strong. It doesn't care that it got reset every time. And don't generate types here. Okay, that's cool. And here is the point. We need to generate a type of the test. We might not need this, but we need to have well, just a second. We might not need this, but because it's generate type, right? I want it to generate the migration as well. I don't need the migration anymore. So I think that's cool. And we will need to have a test because this is the whole problem. This is the problem that we have now, right? We need to TSC, we need to do the same thing as the migration thing. And now this is question mark. We need to output the result to test folder. And then we might use and truffle test JS. So I think that's all we need to do. But what is the question mark? We don't have this yet, so we need to create one. Good. So we will create a thing called, just a second, well, new file called tsconfig. Again, new file called tsconfig.test.json. It's kind of follow the same rule of the tsconfig migrate.json, right? And we copy this one from migrate content and inside the test JSON, and we change a little bit. The extent is the same and the include will be different. This one should be, well, we change the name of the test. We don't want it to be the same name as the final test, so it will be TS. And this one we change to test-ts, and we just leave it the same. It's fine. Okay, that's it. And the question mark, you might have already known what we should do. This one should be the tsconfig.test.json, and that's it. And why not try it again? We now delete all the things which is auto-generated by our code. This one, move to trash, and migration, delete, move to trash, and types, delete, move to trash. Okay, that's clean again. Let's try again. We use yarn type check. Okay, cool. It has something wrong. Deployer will type check. So it has the problem inside the compiler. Well, that's weird. We just go back to the original thing to see if it is working. Not sure if it is the reason, but worth a try. No, now it's working. So this one we should leave it here because this is the type chain library, and then it makes use of the target truffle v5, so we need to let it here. Okay, it makes sense. Let's try it again. Delete everything to make sure everything works from the beginning. We delete this, move to trash. Types, we also delete the types folder. Okay, and then we yarn type check, and cool, now it's working. And one more thing it doesn't do is that, actually I think it's better to have this one here, because it's also a type check, right? Because it generates all the types folder for test, so we make it this way. And we delete this. Pretty cool. I know it's very long line, but I think it makes sense. Yarn type check, try it again. Compile. And general type, okay, everything done, and then we still don't see the type. Try it again, and then let's have a try again. Yarn type check. Okay, and then you see the test folder also been generated, and then now when we use the truffle test, and then it will test the folder inside the test this JS file instead of this TS file, so it went through. Remember that when we add this line of code, just a second, when we added this line of code and then it just went round, but now it's gone through. It means that types already been supported. Everything is pretty cool. So this is the pretty much working fine library temp boilerplate that we need. I will just create and then the final thing is that we can clean it, because we have many like auto-generated code inside, but sometimes we want to delete it from and then try to make sure everything is generated correctly. We want to clean it all, so we make a clean script, and then it will remove those folder build and migrations and test and types. That's all right. And when we just run yarn clean, and then it helps us to clean all this folder, and then everything become clean. I don't know what happened. Okay, that's fine. Okay, that's all. And let me think if I missed anything. I think it's quite cool. Okay, that's it. We can also make a, okay, that's it. And then the next step is that we need to migrate our code from Remix to we copy it. Okay, you can see when we copy and paste. Okay, you can see when we copy and paste this contract CTK contract code inside. Probably we can delete all this thing first to avoid confusion. Delete, move to trash, and this one convert live, delete, move to trash. Now we have CTK only, and then the default migration, and then we need another one, new folder, not folder, I think it's new file, and then pctk.sol, and then we copy our things, pctk.sol to here. Okay. I think okay, we can save it. Okay, now everything is working fine now, and we have our CDK and we have the CDK PCDK here, and we can start doing the migration and test, right? Firstly, we just see the migration. Now it's all not suitable for our project, so we are going to use the probably we need to change the name to color token for this file because it's better to have the same file name as the contract name. That's it. PCDK, here we change the name. This one should be in a capital order, capital letter, and this one should be color token. Okay, and here that's it. Perfect. Now we have it, everything is good, and then we turn it to here, and then this one should be CDK, right? The color token, and this one should be color token. And one more thing is const, we need to have another one. This is proof CDK equal to artifact required. Well, proof CDK. You might have already noticed that there is some syntax highlighting. It's because that we don't have the type folder here. When we run the type check, and then it will go away. Okay. Now we need to deploy this CDK first. Color token, and then we will need to input the argument. The first is the token name, color token with the space and symbol CDK, and just a little bit forget, let's go back to C. The argument CDK, it should be token name, symbol, and total supply. So we will have again 100,000, right? And that's pretty cool. And then secondly, we need to have proof CDK, and this one should be proof, proof color token and PCDK. I think we only have these three. Let's go back to C. PCDK. Oh, we need to have the colorful token address. So now we need to make it a sync function, and then we will have this await. Then after await, we are going to make a ctk object, which is the color token deployed, and this the third argument should be ctk dot address. Okay, we don't need this one anymore. I think that's it. And this one, we don't need this one for now. We comment all this out. Okay, I think that's what we need for now. And then we try to check type, yarn type check, and then it should generate all the types for us. And then it has compilation fail. So it says a different compiler source file require different compile version. So our compiler for us in default is 0.5.16. It's not as good as what we need, so we're gonna change the compiler. We're gonna change the compiler inside the truffle config file, truffle config here, and we are gonna add a new compiler section here, which is compiler compilers, and gonna have the solidity compiler, and version is says point, this one should be good. Okay, save it. Let's try it again. This, well, it says that I defined the solidity version very outdated one, so it's in the migration file, so it should be inside here. Okay, migration contract. Well, it's kind of old actually, so let's try to copy this one and paste it here. Okay, and I think we don't need this anymore. Okay, let's go try it again. Okay, it compiles fine. Okay, generate the types already. Okay, so it's another error. It says that, oh well, should be some issue here. We need to input, not link, this should be deploy. Let's try it again. doesn't have address. So this does not have address. This should have address. Color token here. Deploy it. Okay, I think I need to use await because it is a sync function. Okay, right, returns a promise. It should be good. Okay, okay, now everything is cool. Okay, now we have compiled everything and then we are ready to write the test file, and then let's clean everything for now by yarn clean. Okay, and then change the test name to much more general name, probably test contract test. Cool.
Okay, now we can start making the most important part, which is creating our test script. And let's see how the types can help us to make the bug-free script. Okay. So firstly, we are gonna import our color token from the artifact required, the color token. This will be gotten from the types automatically because it is the global type, which is defined in the type DTS folder file. And this is the proof CTK, and we are gonna make a contract test. The name will be the contract test, and account is a function. And here we can make a here you can see how the types can help us, and we just input whatever we want, and then we will see what the type is this, and it is accounts. If we are just using the default truffle, we don't know, we wouldn't know this is the account, and then we even didn't know there is a callback argument inside here. So now we know it's account. We just put account, and now we just use the it like mocha default test function. First one, we just try as we have done in remix to stake, let users stake, and we should make a sync function inside. And okay, firstly we just define the pctk equal to await proof ctk dot deployed, and we will be able to see what the type of this is the proof ctk instance. This is pulled from the types which is generated by our type chain itself automatically. And we have ctk equal to await color token, and then you can see we have the autocomplete function for the VS Code, which is very good. We save a lot of time. And now we have the instance of this deployed contract of these two, right? And now remember that we have done in Remix was that we grant the rule to grant the minter and the burner rule to pctk, right? So we need to do the same thing. Await ctk grant rule. See, this is very important. We have the autocomplete, and then the TypeScript knows that what the function is inside the CTK. Before we don't know, the editor doesn't give us the autocomplete. We need to remember by ourselves, and sometimes we have typo, and then it makes a lot of trouble for us. Now we don't have this trouble, and then it saves us so much, a lot of time, and then it make our lives much easier. Grant rule, right? And then it says the first one is the rule. Okay, we do remember that we need to use the web3 utils well sha3, and then this one should be the minter rule, and the next argument is the account, right? We need to grant pctk address. Okay, let's see, it has a highlighting here. It says the string null is not assignable to parameter string. Means this one could be null, but we know that this one will not be null, so we can just do the assertion here, and then await ctk.grant rule. We just copy that, and this one is burner rule. That's it. And then we can see await. Now we grant the rule, we can stake. Now we try to stake pctk.stake. Okay, very good. I love this auto completion from. Okay, good. I can also see this one is also very good, and we can see what we can do here is guess, and then we can do from, we can do any other thing, guess price. Very nice, right? From account 0, which is the deployer, and now after staking we can check the total supply of the CTK, total CTK total supply, and to see if it decremented by 1 equal to balance of total supply. I think that's it. And we can see it is big number. Okay, and we just console log it out. Total supply CTK number. Okay, so and then we can test. Okay, you can see here it is the total supply of the CTK changed from 100,000 to 99,000, which is exactly the same result as what we have done in the remix. Here you can see, well, just a second. Okay, you can see here, and then the total supplied here. Get a little bit laggy, but just give it a second. Okay, it's exactly the same result as what we have done in the test script, and then this is much faster than doing the same thing inside the README manually, step by step, and then we can do it on the script automatically on the truffle with the TypeScript, and then with the auto completion and all those the benefit from TypeScript. Okay, so it is all for today. I hope you enjoyed the video. Thank you. I'll see you next time.